Hello everyone, welcome to Gradeup. Today we are here for the BYSP session on machine design. All the theory lectures have been completed of this subject. So we will be taking around 15 to 18 questions of this subject of machine design. That will be in the two PYSPs. So first see this one, PYSP 1. We will be taking around 7-8 questions in this and 7-8 in the next one. Okay, so let us begin. Let us read the question first and then try to figure out the concept and then try to solve it. Okay, so see this. This is the question asked in GATE 2017 set 1. Let us read what this question says. A machine element has an ultimate strength sigma u of 600 Newton per mm square and endurance limit sigma en of 250 Newton per mm square. The fatigue curve for the element on a log plot is shown below. Okay, this is the curve that is shown. If the element is to be designed for a finite life of 10,000 cycles, then the maximum amplitude of a completely reversed operating stress is in Newton per mm square. This is to be found out. Okay, so sigma u has been given and sigma en, that is the endurance limit, has also been given. And it is saying that we have to design this for a finite life of 10 raised to the power 4 cycles. This was for 10 to the power 6 cycles. Now we have to design this for 10 raised to the power 4 cycles. Okay. So let us first of all write down some values. Sigma u given values 600. Okay. Megapascal or Newton per mm square. Sigma en as 250 Newton per mm square or megapascal. Okay. That is same. And then for n equal to 10 to the power 4 cycles, we have to find out. Okay. So how we will do this? See, we will use a linear relationship in this case, that is log of 0.8, because you know that 10 raised to the power 4 would be somewhat here. Okay. This will be 10 to the power 4. Okay. And we have to find out this value. Okay, what will be this corresponding value? This we have to find out. So we will use log of 0.8 sigma mu. Why 0.8? Because this is given here. Minus log of en. Log of sigma en upon, this is for value 10 to the power 3, that is 3 minus 6, because 10 log base 10 to the power 3 is nothing but 3, and similarly goes for 6 also. And this will be equal to, we have to find it out for this value, this minus this. Okay, so log 0.8 sigma mu minus log sigma. This sigma is only what we have to find out. Okay, let us write sigma upon 3 minus 4. Okay, so now just solving this, we have the values of all this. So we will get log 0.8 into sigma mu is 600, so this will be 480 minus log 250 upon 3 minus 6 is minus 3, okay, which is equal to, this is again log 480 minus log sigma upon minus 1. This minus and minus goes cancel. Now just substituting the values, we get this value as 2.6812 minus 2.3979 upon 3 equal to 2.6812 minus log of sigma upon 1. So on solving this, we get the value of log sigma is equal to 2.5868, but we have to find out the value of sigma. So how to find out the value of sigma? Sigma is equal to 10 to the power of 2.5868. Why 10 to the power? Because this is log. Okay, and this is nothing but log base 10. That's why 10 to the power sigma or 10 to the power this value gives you sigma. So the value of sigma will come as 386.16. Okay, megapascal. So this value, the sigma value will be 386.816 megapascal or Newton per mm square, 386.16. Okay, this is a very simple question. Just we have to make a linear relationship in this log graph paper, and then we can find out the value. Just you have to remember that these values have not, you do not need to take them just like this 10 to the power 3, 10 to the power 6, because we have to take it on a log graph. Okay, so 10 to the power 3 is equal to 3. Similarly, 10 to the power log base 10, 10 to the power 6 equal to 6. So that in this way we have to solve this problem. Okay, I hope this is a very easy problem. Okay, so now let us see the next problem. Asked in GATE 2015 set 1. A horizontal plate has been jointed to a vertical post using 4 rivets. Okay, this is a riveted joint question arranged as shown in the figure. The magnitude of the load on the worst loaded rivet in Newton is. Okay, so as you know, in this type of questions, what we do, see this. First of all, this is a symmetric arrangement of the 4 rivets. Let me write them, the name as 1, 2, 3 and 4. Okay, and due to the symmetry, its center of gravity will lie at the geometric center of these arrangements. Okay, so then what we do in these questions, we know that what we have to do first, we have to make an equivalent load at this point. Okay, means this arrangement we have studied in the chapter of riveted joints, that first of all this force means this eccentric load will be replaced by a similarly acting axial load at this point at center of gravity plus a moment, and that moment will be equal to this load into this distance. Okay, so this will be 400 into 500 Newton mm. Okay, Newton mm. This will be m at this point. Okay, then this force, this axial load will cause primary shear stress. Okay, this load, let me draw this diagram once again here for the better understanding. Okay, see, these are 4. 1, 2, 3 and 4, and we are having a load this way. Okay, this is 400 newtons. So this will cause the primary shear stress in all the 4 rivets in this way. Okay, the primary shear stress in all these 4 types of rivets, that is one, or let me draw it in a different manner. One, 2, 3 and 4. So this load, that is the axial load of 400 Newton, will be giving the direct shear stress or the primary shear stress in this way. Okay, that will be P1 dash, P2 dash, P3 dash and P4 dash. Okay, so that means P1 dash is equal to P2 dash is equal to P3 dash equal to P4 dash, and that is equal to nothing but the force upon area. Okay, so simply the force upon area, or basically this is the force. So we are not concerned with finding out the stress. So this will be equal to 400 Newton divided by 4, because there are 4 stress joints, 4 riveted joints. So this will be 100 Newton. These are the primary shear stresses that is acting on a riveted joint. Then I told you that there will be, this is 400 and this will be a moment, that is m equal to 400 into 500 Newton mm. Okay, so this will cause a these are the distances R1, R2, R3 and R4. Okay, so these are the, since this is acting in a clockwise direction, so there will be counterclockwise that will be acting at this point. Okay, somewhat like this. This way. This will be P2 double dash, P1 double dash, P3 double dash and P4 double dash, and these are secondary shear stresses. Okay, these are secondary shear stresses, and these are the primary shear stress. Primary shear stress or primary shear force. Primary shear force. Okay, not the stress but the force. Okay, primary means this will cause the primary shear stress, but these are still the only the forces. Okay, secondary shear forces and primary shear forces. Okay, so what they will be, we know that if we consider any one of them, they are directly proportional to their distance from the center of gravity, that is, they are directly proportional to r1. Okay, and when we also know one thing, that P1 double dash, just giving it this way, so this becomes this is the constant of proportionality. Okay, and also we know that P into E, that is this one, P into E will be equal to the effect. This is the applied effect, and this is the effect that is the induced due to the forces, so their moments will be equal. Okay, so that will be P1 double dash into R1 plus P2 double dash into R2 plus P3 double dash into R4. I am solving this question in a very detailed manner. Okay, if you have the practice, or if you have the idea, then you can skip some of the steps to save your time during the examination. Okay, and also we know that R1, in this case R1 is equal to R2 is equal to R3 is equal to R4 because of symmetry. Okay, and what is this? See, this value, because this is also at 40 and this is also at 40. Okay, this is also at 40 and this part is also 40. So the center of gravity will lie at 20 from above and 20 from this side. Okay, so this we will come as 20 square plus 20 square, because we are finding this distance. Okay, this is also 20, this is also 20, so this will become 20 square plus 20 square root because of the Pythagoras theorem. So we get this value as 28.28 mm. Okay, this is the value of R1. Okay, next, because of this equation and this equation, we know that P1, P into E will be equal to P1 double dash is CR1. Okay, CR1 plus CR2 plus CR3 plus CR4, and all these are equal, so this will become P into E is equal to 4 times of C into R. Okay, so from here we know the value of P, we know the value of E and also R, so from here we can find out the value of C, that is P cross E upon 4R. Okay, so P is 400 Newton, this value is 500 mm divided by 4 into 28.28, the value of R we have just now calculated. This value, okay, sorry, one thing I'll excluded. P1 is equal to CR1 and one more R1 will come here, so this will become a square. Okay, please, sorry for this mistake. This will come as R square, and this R square will be this much square, or this will basically be 800. Okay, 400 into 500 upon 4 into 800. So this value we will get as how much? This value will come as 62.5 mm, Newton per mm. Okay, this value we have got. Now P1 double dash is equal to P2 double dash is equal to P3 double dash is equal to P4 double dash, and they are all equal to C into R. Okay, C value is this 62.5, R value is 28.28, so we get this value as 1767.77 newtons. Okay, but these are still the primary and the secondary shear forces what we have found out. We still need to find out the load on the worst loaded rivet. So first of all we have to find out that which is the worst loaded rivet. Okay, see, in this case, in these cases, either rivet 2 or rivet 4 is the worst loaded rivet. Okay, because the forces are acting in this way. I am telling you this, and this you have to remember in such kind of arrangement. The rivet 2 and rivet 4 are the worst loaded rivets. Okay, the stresses will be more in those parts. So we take 2. You can find it out in 1 and 3 also. You will find out that the forces or the stresses induced in 1 and 3 will be less than that induced in 2 and 4. Okay, so just see, now we are considering the rivet as 2. So this is rivet 2. There is one force that is acting this way, that is P2, and there is this P2 dash, sorry, okay, and this is P2 double dash that is acting in this way. So if we consider, if we join it vectorially, and so this will come out to be P2 double dash, this angle is 45 because of the symmetry, there is 90 degree and this is the angle that is going on, that will be perpendicular. So this will come out to be, this means this will be sine, okay, this will be sine 45 and this side will come as P2 double dash cos 45, okay. So net horizontal force will be equal to this P2 dash cos 45, or P2 dash cos 45 will come out to be, if you find P2 dash cos 45, you will find out P2 value is this P2 double dash, and cos 45 you already know 1 by root 2, you can find out this value will come as 1250 newtons, okay. And the net vertical force will come out to be, this is again P2 sine 45, that is again 1250 plus P2 dash, and the value of P2 dash we have found it out as 100, so this will come out to be 350 Newton, okay. So net we have to find out the net force. Net force is nothing but horizontal force square plus vertical force square root over, okay. So that means it's 1250 square plus 1350 square and root, okay. So this value will come out to be 1839.84 Newton, okay. This is the net force and this is only the answer, that is 1839.84 and in newtons, okay. So this was not this was basically a very conceptual question on the riveted joint, that too of the eccentric loading. If you find it difficult, then you must try to solve it fast, and you can skip all these steps. These steps I have just written or just shown so that you could not confuse, or you could not get confused, or you can understand it in a better way. Otherwise, this question is very easy, you can solve it in 3 to 4 minutes very easily. Just focus on the equations and just focus on your steps and calculations, okay. Okay, now the next question of bolted joint, 2016 set 3. A bolted joint has 4 bolts arranged as shown in figure, okay. The cross sectional area of each bolt is 25 mm square. A torque T of 200 Newton meter is acting on the joint. Now, neglecting the friction due to the clamping force, the maximum shear stress in a bolt is. What is the maximum shear stress? That we have to find out, okay. See, in this case, if we suppose that the torque is applied in a anti-clockwise, if we are seeing from this side, okay, if we are viewing it from this side, and we see that this is a torque that is going in an anti-clockwise direction, so we just put it an anti-clockwise, that is T. So to counter this, there will be, let me write this as 1, 2, 3 and 4, okay. So there will be some counterbalancing moment due to all this, okay. Let us write it as F1, this is F2, this is F3 and this is F4, okay. So T, so the resultant of these, that is the externally applied load or externally applied moment, and the internally induced moment due to these forces, okay, that will be same, and these are the distances, that is the R, all the distances are R, that is equal to the radius of this, okay. The diameter has been given as 100, so the radius will be 50, okay. So F1 into R plus F2 into R plus F3 into R plus F4 into R minus T is equal to 0, and also F1 will be equal to F2 will be equal to F3 will be equal to F4. Why? Will be equal to some F, because of the symmetrical arrangement of the bolts, okay, symmetrical arrangement of these bolts. So we can write this as 4FR is equal to T, or we can find out the value of F from here, that is T upon 4F, okay. The value of T is 200 divided by 4 into the value, oh sorry, this is R, okay. R value is 100 is the diameter, so 50 will be R, but that will be in mm, okay, or that will be in mm, so that will be multiplying it by 1000. So just now finding out the value, this goes off by this and we are left with F is equal to 1000 Newton. Okay, this is the force that is induced, that due to this applied moment. So just now we need to find out the stress. Stress is nothing but force upon the area. So force is 1000 divided by area given as 25. This is in Newton, this is in mm square. So we get the answer as 40 Newton per mm square or 40 megapascal. Okay, so the answer for this question is 40. This is a very simple question. Just you need to apply this concept, this one and then this one. Okay, very simple problem. Okay. Now let us see next question. Again, it's a riveted lap joint question. Okay, asked in 2017 set 1. Consider the schematic of a riveted lap joint subjected to tensile load F as shown below. Let D be the diameter of the rivets. Okay, this is D is the diameter of the rivets, though the figure may not be that much clear, but I will try to explain you, and also the terms and terminologies have been written here. Let D be the diameter of the rivets and SF be the maximum permissible tensile stress in the plates. Okay, then what should be the minimum value? Okay, what should be the minimum value of for the thickness of the plates to guard against tensile failure of the plates? Okay, and assume the plates to be identical. Okay, now let us see how this question will be solved. We know one thing, for it is saying for the tensile failure. Okay, so for tensile failure, of plates, the stress that is induced between the plates or between the rivets, okay, tensile force divided by area between rivets, area of plate between rivets, that must be less than equal to the maximum value, and the maximum value has been given to you as SF. Okay, the tensile force applied is F divided by the area between the rivets. See, this area has been given to you from diameter to diameter, that has been given to you as W by 2, this is W by 4. Okay, these are some of the marginal values. The total width of the plate is W. So W minus 2D will be the area between the plates or between this length, because 2D is the diameter. Okay, it has given that D is the diameter and there are 2 rivets of such diameter. So it will be W minus 2D into T, that is the thickness, that is less than equal to SF. Then T will be greater than equal to F upon SF into W minus 2D. So it is coming as the greater than equal to, that means that this has been asked as the minimum value. Okay, so the minimum value or the minimum thickness comes out to be F upon SF into W minus 2D. So the answer for this question is, the correct option is option number A. Okay, simple problem. Just you need to understand this concept that for the tensile failure of plates, the area is like this. Okay, the area taken between this way, area of plate between the rivets. Okay, let us see the next problem. This is from the problem of welded joint. Very simple problem. Just we have to understand the types of joints, or basically the shape. What kind of shape is shown by this type of weld. Okay, this type of weld represented by the shaded region in the figure is A. I don't think that I need to explain anything on this one. The correct option for this is option number C. Just by seeing also you can understand. So you can see that this type of question are also being asked from this subject. The theoretical problem very conceptual. Just by looking at the figure you can make it out that which kind of figure is this. So fillet joint, T joint, V joint, U joint, all this you must be clear with that what kind of welding is shown. Okay, now see the next question. As there has no question been asked from the topics of keys, so I am taking one example of keys. Let us see that how to solve this. Okay, it is required to design a square key for fixing a gear on a shaft of 25 mm diameter. Okay, the shaft is transmitting 15 kilowatt power at 720 rpm to the gear. The key is made of steel for 50 C4. This is a grade of steel. Okay, so whose tensile yield strength in tension, that is the SYT is given as 460 Newton per mm square, and the factor of safety is 3. So for key material, the yield strength in compression can be assumed to be equal to the yield strength in tension. Then we have to determine the dimensions of the key. Though this will be a bit of lengthier problem, because this has been taken from some standard textbook, because there has no question been asked from this subject so far. So I will just try to make you explain or make you understand that what kind of things can be asked from this topic. Okay, see, the power, first of all, let us write some of the given values. That the power in kilowatt has been given to you as 15. Then the N, that is the RPM, is given as 720 RPM. The value of SYT given as 460 megapascal or Newton per mm square. Factor of safety as 3. And one more thing is given, that is the diameter of the shaft, that is 25 mm diameter. Okay, so first of all, we know the compression failure, that SYC is equal to SYT for the compression failure, and that becomes equal to 460. Okay, this is 460 Newton per mm square. So the compressive stress, that is sigma C, will be SYC divided by the factor of safety. So this is 460 divided by 3 will give you 153.33 Newton per mm square. Okay, so for the this is for the compression stress. Then for the shear stress, we know that SYS is equal to SYT divided by 2. This we already know from the subject of from the subject of strength of materials. In the case of theories of failure, we have seen this. Okay, so this value will come out to be 230, that is 460 divided by 2, that is 230 Newton per mm square. Okay, so the shear stress will be equal to SYS divided by factor of safety. This will be 230 divided by 3. This will come out to be 76.67 Newton per mm square. These are the values of stresses, the compression stress and the tensile or the shear stress that we have found out. Now, see, the torque transmitted, torque transmitted is given by, MT is given by 60 into 10 to the power 6, then the power in kilowatt divided by 2 pi n. Okay, so just now substituting the values, 60 into 10 to the power 6, the power in kilowatt is 15 upon 2 into pi into the value of n is 720. Okay, on solving this, we will get this value as 198,943.68 Newton mm. Okay, this is the torque transmitted that we have found out. Now, what we have to do? Now the length of the key. We have to find out the length of the key. Okay, the length of key. Okay, and one more thing, there is a standard dimension, there is a standard general industrial practice that the height and width of the key, this is a square key, so they will be equal, and they are equal to that 1/4 of the diameter of the shaft. Okay, so 25 was the diameter, this was given as 4, so this will be 6.25, or we can take it as 6 mm. Why? Because 6.25 mm diameter or 6.25 height and breadth key we will not make. Okay, we will take it as a 6 mm. So now we have to find out the length of the key. So for shear failure, okay, we have the shear stress, so due to that there will be shear failure. So for shear failure, the length of the key is given by 2mt divided by db tau. Okay, so 2 into this value, that is 198,943.68 divided by d is 6, d is 25, b is 6, d is 25, and the value of tau we have got as 76.67. So on solving this, we will get this value as 34.6 mm as L. Okay, and for the crushing failure, due to the compressive stress or compressive force, there will be crushing failure. So for crushing failure, the length is given by 4mt by sigma c d into h. Okay, so 4 into 198,943.68 divided by 153.33 into diameter 25, height again 6. Again this value will come out to be 34.6 mm. So the dimensions for the keys, that is L into B into H, will come as 35, maybe 34.6 or 35 into B is 6 into this is 6 mm. So whatever has been asked, Okay, these are basically the industrial practices that are generally practiced in the practical applications. But if such kind of relations are required for solving this example, then this will be obviously given by in the examination. Okay, so you don't have to worry that you have to remember each and everything of this sort. This was just the kind of example that I need to tell you that how to solve. If you get across the question on keys in the examination, then how to solve this, what is the procedure. Okay, so you have to find out for shear failure, for crushing failure. If it has been asked specifically that for shear failure what is the length, or for crushing failure what is the length, then you can find out using the single formula. But if it is not asked, then you have to check both using both the criterions of failure. Okay, now the last question of this PYSP session, that is again the example on belt drive, because the belt drive question has also not been asked, but it could be. Okay, so this will be a lengthier problem again, because again it has been taken from a standard textbook, and I will try to solve and show you each and every step what could be asked and how to solve this kind of problem. Okay, so first let us read it out. The layout of a leather belt drive transmitting 15 kilowatt of power is shown in figure. Okay, the center distance between the pulleys is twice the diameter of the bigger pulley. The belt should operate at a velocity of 20 meter per second approximately. Okay, please read each and every word carefully. And the stresses in the belt should not exceed 2.25 Newton per mm square, that is megapascal. The density of leather is 0.95 gram per cc, and the coefficient of friction is 0.35. The thickness of the belt is 5 mm. Then we have to calculate the diameter of the pulleys, the length and width of the belt, and the belt tensions. Okay, this is the schematic diagram that has been shown. Okay, so first of all, let us write the values that have been given. That is the power in kilowatt given as 15, which the belt drive is transmitting. Then the velocity has been given as 20 meter per second. Okay, this we will correct it afterwards because this has given as approximately. Okay, so see the procedure first. Then see the center distance is equal to 2d, that is twice the diameter of the bigger pulley. Okay, t, that is the thickness given as 5 mm. Rho, that is the density of the belt material given as 0.95 gram per cc. Okay, the sigma, that is the sigma maximum which could be induced is 2.25 Newton per mm square, and the coefficient of friction, that is F, has been given to you as 0.35. Okay, so first of all, find out the diameter of the pulleys. This one is simple, that can be found out directly. Diameter of pulleys. Okay, diameter of pulleys is velocity is equal to, you know, that is pi dn divided by 60. Okay, and then doing it 1000 because we will find it out in mm. Okay, so from here we can use the d is equal to 60 into 1000 into v upon pi into n. Okay, all the values we are having. V is this, n is 720. No, n has also been given, I think. Not given. Okay, n has been shown here. Sorry, n has been shown here in the diagram itself. That is 1440 for the smaller one. This we are finding for the smaller one. So just substituting this value, we will get this value as 265.26 mm, which can be approximated to 270. Okay, 270 mm. Okay, then d we can find it out. That is 270. Because n1 d1 equal to n2 d2, so 270 into 1440 upon 480. Okay, this using the linear relation we find this value as 810 mm. Okay, this is 810 mm. Now for finding out the belt length, first of all we need to find out c. C is equal to twice of d, that is given, twice of 810, this comes out to be 1620 mm. Now the length of the belt, the formula for length of the belt, this is an open belt drive. Okay, this is a open belt drive. This you can see from the diagram. So the length of the belt is given as 2c plus pi d plus d divided by 2 plus d minus d whole square divided by 4c. Okay, all the values you have, c, D and D, all the values we have. So from here we can find out this value as 4981.46 mm. This is the length of the belt. Okay, so in this question it has been asked the diameter of the pulleys. This we have found out 270, 810, and the length of the belt has also been found out, that is 4981.46 mm. Now what we have to find out? Now we have to find out the other thing, that is the width and the belt tensions. Okay, so how to do that? See, first of all we will find out the correct belt velocity. Okay, the correct belt velocity due to the diameter what we have found out will be pi dn upon 60 into 1000. So just substituting the value, that is pi, diameter d small one is 270 into 1440 divided by 60 into 1000. So we get this value as 20.36. Okay, so that was approximate, so just we are getting this value. Now we will find out the angle of wrap, that is alpha s equal to, for the smaller pulley is 180 minus sine inverse twice sine inverse d minus d upon 2c. Okay, all the values we are having, d minus d, 2c, all values we are having, so we will get this value as 160.8 degrees. Okay, so converting it into radians, we get it as 160.8 divided by 180 into pi. This value will get as 2.81 radians. Okay, please see each and every step very carefully. We have to use the value of wrap angle, that is either for the small pulley or bigger pulley. We are considering here it for a small pulley in radians. Okay, then what we do, we find out the volume of 1 meter length of belt. Okay, so the volume is length into breadth into thickness. Okay, that is length into breadth into thickness. Okay, so length for 1 meter is 1 into b upon 1000. Okay, this is the width but we have to calculate, and this we are considering in mm, that's why 1000 into 5, that is thickness, again divided by 1000. So we get this value as 5b into 10 to the power minus 6, and that is in meter cube. Okay, this is the volume. So for the mass of 1 meter, mass of 1 meter of belt will be what? Mass of 1 meter of belt, that will be simply volume multiplied by density. Okay, volume multiplied by density. So volume is 5b into 10 to the power minus 6. Now considering the value of rho in kg per meter cube, that is 9.95 multiplied by 1000. Okay, this will come as kg per meter. Okay, so this will come out to be as 4.75 b into 10 to the power minus 3 kg per meter. This is the mass of 1 meter of belt. Okay, then we have to find out something else, that is mv square. Why we are finding out this, that you will come to know right now. 4.75 b into 10 to the power minus 3 into v square. V is 20.36. Now we have to use this one, so we get this value as 1.97 b. Okay, then we have to find out one more thing, that is e raised to the power f alpha. E is okay, f is given as 0.35. Okay, 0.35 into this value, that is the value of angle in radian, 2.81. so this value we get as 2.67. okay, now using the relation that is P1 minus mv square upon P2 minus mv square is equal to e raised to the power f of alpha. Okay, where P1 and P2 are the tensions. Okay, so from here this equation will be come as P1 minus 1.97 b upon P2 minus 1.97 b is equal to 2.67, and on solving this and on simplifying this, we will get this equation as P1 minus 2.67 P2 plus 3.29 b is equal to 0. Let us take this as equation number 1. Okay, then we haven't used one more thing, that is of the maximum stress. We have to use that. Okay, maximum stress, that is sigma max, is equal to the maximum tension upon the area of cross section. Okay, so maximum tension is P1 upon the area of cross section is nothing but B into T, and T is 5. Okay, so this will be P1 upon 5B, and that this value has been given to you as 2.25. So from here we will get the value of P1 as 11.75. Okay, 11.25, sorry, 11.25 B times of Newton. This is equation number 2. And the last equation what we can use is for the power transmitted. The power transmitted in kilowatt is given as P1 minus P2 into V, that is the velocity, divided by 1000. Okay, so power transmitted, from here we can find out the value of P1 minus P2. The P1 minus P2 will be equal to power transmitted in kilowatt given as 15 into 1000 and divided by the velocity, that is 20.36. So we get this value as 736.374 newtons. This is P1 minus P2. This is equation number 3. This is the P1 in terms of B. Okay, so what you do, just substitute this P1 equal to this times of B. From here also P1 P2, P1 minus P2. Okay, so just solving these three equations 1, 2 and 3 simultaneously, we will get the values as B equal to 127.02 mm, P1 is equal to 1428.98 newtons, and P2 as 692.26 newton. So these are the belt tensions and these are the widths. The length has already we have found out, and also the diameter of the pulleys. Okay, this was though a very lengthy question. In terms of examination, it won't be asked in this way. Okay, some part of this question may be asked. Okay, so this was just to make you familiar that what are the concepts that are involved in solving the questions of belt tensions, and if you get such kind of questions in the examination, then how you have to proceed. Okay, so here we are concluding the PYSP session 1 on machine design. Few more topics are left, like the brakes, clutches, and the bearings and all, the gears. Okay, the gears, though no question has been asked, so we won't be taking it that, because the chances of the question being asked from that topic is also very less. Okay, in terms of gears, the questions, simple questions come for finding out the module and the addendum and all those, what that we have covered in the subject of theory of machines. Okay, so few more topics left. We will be solving some of the questions in the next PYSP sessions. So if you have any problems in these questions, in understanding in the concepts or anything, you can write to us on the Gradeup app and on the website. Your feedbacks are always welcome. So see you in the next class with the next PYSP session on machine design. Till then, thank you, take care, bye.